This will be video 4 in a series of videos dealing with the review for our midterm exam. We're going to pick it up at problem 22, which begins our work on Unit 5, the last unit in consideration for the midterm exam. Unit 5 is taking a look at linear programming problems. So I'm going to go ahead and share my visualizer, and we'll take a look at what's going to happen as we move through this. Okay, we're a little crooked. Problem 22, we're asked to represent two variables that we're going to use to solve the problem. Problem references making clocks, okay? We can make pine, or we can make, looks like the other one might be oak. So those probably are going to represent how many of each of those particular clocks. We have some freedom in terms of which we'll assign to X and which we'll assign to Y. We'll see that as we flip to the next page. Part B of this problem asks us to write an objective function for the problem that we will seek to maximize or minimize, right? And basically in this context, it's looking for profit. So it might be worth looking at as we take a look at what we've got for our objective function, we can make a profit of $3 for each pine clock that we sell, and make a profit of $4 for each oak clock that we sell. Those are going to be useful facts as we move to the next page and proceed with our solutions on 22. Here we go. And then we'll take a look at part C in context as we get ready to go. Part A asks us to represent our variables. I've chosen to let X represent the number of pine clocks that are made, and in turn Y to represent the number of oak clocks that are made. You really do have choice there. One isn't any necessarily better than the other, but you must clearly represent which of your variables represents the amount of which kind of clock. Part B, if you remember, asks us to write a function, an objective function that we're trying to maximize, in this case, profit. So I chose P for profit. I thought that was pretty crafty. If you remember, we have a profit of $3 for each pine clock that we make and sell. And we have a profit of $4 for each oak clock. So your profit package is 3 times X, where X is the number of pines, added to 4 times Y, where Y is the number of oak clocks. So that takes care of part B. All right, the constraints, which is what we're asked to do in part C, and we're not asked to do any graphing. We're simply asked to come up with constraints. If you remember from the original problem, there's a constraint dealing with time. It took 2 hours to make each of the pine clocks. It takes 2 hours to make each of the oak clocks, and the maximum time allowed for work was 20. So if we go 2 times X, where X is the number of pines, plus 2 times Y, where Y is the number of oaks, that total hour commitment must be less than or equal to 20, and that's our first constraint. Our second constraint on this problem deals with varnish. Each of the pine clocks needs 1 quart of varnish, and each of the oak clocks needs 4. So again, there's that 1 in front of the X that you see on our second constraint. Probably no more visible with the 4 in terms of 4Y, 4 for each of the oaks. And we have a max at 16 quarts of varnish. So our varnish constraint, if you will, is 1X plus 4Y has to be less than or equal to 16. The last 2 constraints are kind of just there. I think they're intuitive. You can't have a negative number of either kind of clocks. So whatever X is, it has to be greater than or equal to 0. And in a similar fashion, Y would also have to be greater than or equal to 0. And that's all we were asked to do on problem number 22. Moving to 23, I cut out all of the work. There's no constraints for you to look at. There are no variables to represent. There's no graph to do. I simply gave you the objective function at P equals 60X plus 50Y. I've also given you the coordinates for each of your vertex points on the feasibility region, and you can see them listed on the left column at 0, 0, 11, 0, 9, 4, 5, 8, and lastly 0, 10. And really all you have to do on this problem is plug those coordinates in for X and Y, and you are calculating a profit or a p-value in each case. Now, if you put zeros in for both, you're going to just get a profit of 0. And as you move down that right side column, what you're going to see is in each case, your X value gets substituted and multiplies 60, and your Y value gets substituted and multiplies 50, and then we find the total profit. So running down that column, you're going to see that at 11.0, the profit was 660. At 9.4, where 9 went in for X and 4 went in for Y, the profit was 740. On 5.8, the profit comes up at 700. And last but not least, if you sell 0 X's and 10 Y's, the profit comes in at 500. The maximum, just visually there, looks like our biggest P value was 740. So the maximum value would be 740, probably dollars. And that would be ascertained if we had an X value at 9 and a Y value at 4. And that's the end of problem 23. Problem 24, as we switch pages, has us basically take the whole idea of linear programming and run it start to bottom. I gave you the system of constraints. I gave you the objective function. Your first challenge is to find the feasibility region. So you have to graph those. All right, X is greater than or equal to 4 will be a vertical line 4 units to the right. So if you look at the graph shaping up, you'll see that we have a vertical line at X equals 4 right there, okay? Second constraint says Y has to be greater than or equal to 1. That's a horizontal line running 1 unit up. If you take a look at that, there he goes, running straight across 1 unit high. All right, another constraint, X has to be less than or equal to 8. So again, you're seeing a vertical line sitting 8 units to the right. So we've got 3 constraints that were simply horizontal or vertical lines. The last of those constraints, 2x plus y less than or equal to 18, I went ahead and solved for y just to get slope and intercept for us. All right, in that case, our y-intercept is 18, our slope is -2. So you kind of look at the axis and you'll see a dot over here at 0, 18. That's our y-intercept. Our slope is -2. So we'll go down 2 and right 1. You can almost see a dot out there. It looks to be at 116. And then I've got a subsequent set of dots that made it just a little easier to maybe draw a little more accurate slanted line. All right, now the next challenge is to get those corner spots. You can see I've shaded in our feasibility region. It kind of looks like a triangle with a little cutoff on the right side, a little vertical action. So it looks like we've got corner spots at 410, at 4.1, again at 8.1, and the top of that little vertical stack at 8.2. So we'll take each of those corner spots, each of those vertex locations, and we will evaluate the objective function to try to find out our maximum or our minimum. So as I slide here, I brought back your objective function. It was P equals 5x plus 10y. That was typed above. And you're simply going to put each of those ordered pairs in one at a time, with your X value being multiplied by 5 and your Y value being multiplied by 10. I took them one at a time. First, I did 8.1. All right, again, there's no rhyme, no reason to which order. You need to do all of them. All right, so at 8.1, 8 goes in for X, multiplies 5, 1 goes in for Y, multiplies 10, and your P value is 50. If you use 8.2, again, 8 goes in for X, 2 goes in for Y, and you get a P value of 60. At 4.1, 4 goes in for X and 1 goes in for Y. The P value is 30. Looks like we're going to get the answer we're seeking here on our last guy at 4.10. All right, so 4 in for X, 10 in for Y. 5 times 4 would be 20. 10 times 10 would be 100, and that makes a p-value of 120. And we've got what we were asked to find, the maximum value for that objective function at 120. And this wraps our solution set for midterm review, and we'll get you into the midterm exam as soon as you're ready. Thank you for watching video 4.